Today's learning intention is to calculate the scalar product of two vectors in component form. So the scalar product of two vectors is given by the equation a dot b equals a1 times b1 plus a2 times b2 plus a3 times b3, where a is the vector in component form a1, a2 and a3, and b is the vector components b1, b2, b3. And that's a bit of a mouthful, but it's given in the exam, it's given on the formula sheet. Basically what it's saying is to find the scalar product of two vectors, multiply together the corresponding components, and then add them all together. Let's look at some examples. Example 1. Find p dot q, that's the scalar product of the vectors p and q, given that p is the vector 1, 2, negative 3 and q is the vector 2, 2, 3. Now from the formula sheet, we've got the scalar product of two vectors a and b, but in your question you have two vectors p and q, so you must rewrite it in the context of the question. So the scalar product of the vectors p and q is p dot q equals p1 q1 plus p2 q2 plus p3 q3. So the scalar product of p and q equals 1 times 2, add on 2 times 2, add on negative 3 times 3. So that gives me the scalar product p dot q equals 2 plus 4, take away 9, which equals negative 3. Let's try another example now. Example 2. If A is the point 2, 3, 9, B is the point 1, 4, negative 2, and C is the point minus 1, 3, negative 6, calculate the scalar product of the vectors AB and AC. This is a bit more tricky. We've got individual coordinates and we're going to have to find the vectors. It's useful to look at a diagram. Okay, we've got the vector AB and the vector AC on the diagram and the points shown. So first of all, we're going to have to work out the components of the vector AB. So if I'm at point A, what do I have to do to get to point B? I'm also going to have to work out the vector AC. So again, have a think about it. At the point A, what do I have to do to the coordinates to get to the point C? So the vector AB equals negative 1, 1, minus 11. And the vector AC equals the vector negative 3, 0, negative 15. So now I want to work out the scalar product of these two vectors. So again, remember, all we have to do is multiply together the corresponding components and then add them all together. So AB dot AC, the scalar product of the vectors AB and AC, equals, I've got minus 1 times minus 3, add on 1 times 0, add on minus 11 times negative 15. That equals 3 plus 0 plus 165, which equals 168. Now try these examples on your own. Calculate the scalar products for each pair of vectors. You should really pause this video just now and take a couple of minutes to complete the questions in your jotters. Once you're ready, come back and I'll reveal the answers. Hopefully that's you ready now for the answers. The answers to question 1, scalar product A dot B equals 34. For example 2, the scalar product of the two vectors F dot G equals 11. And for question 3, the scalar product of the vectors QP and QR equals negative 15. So how did you get on? It's time now to self-assess your progress. Let's look at your RAG status. Remember, if you're having problems, can you identify where your problems are? Is it multiplying out negative numbers? Or is it the concept of scalar product itself? Please see your teacher as soon as possible for extra help. For extra practice, you can also try page 261, exercise 13p. So what have we learned today? The scalar product in component form is given by this equation. Now this formula is given to you in the exam. You don't have to memorise it, but you do have to remember how to use it and how to problem solve using this equation. In class, we'll go into more advanced problem solving and past paper questions.